Welcome back with another video on TryHackMe.com. This is Zaheen Nazir, and today we're gonna go with the OWASP Top 10 2021. But before we do that, I'm planning to show you overall progress that I made so far on the Hack the Box and what content I will be bringing on this channel. So let's get into it. Before we move on, let me show you. This is the learning roadmap, and as you can see, I already completed the junior pen tester already, and some of the things are remaining in the web fundamentals. And after that, we're gonna go with the web application penetration testing, and after that, we will also complete the red teaming as well. Okay, so this is what I'm gonna bring on the TryHackMe side. There is another path on the Hack the Box. As you can see, I'm gonna go with the retired machines as well. I will be starting with the Nibble, which I already pawned and I have access to this machine. I can do the walkthrough of this machine because it is a retired machine, so this will be really easy for us to basically start with. So I already have a pro level subscription, I think VIP plus, or yeah, I have VIP plus subscription of this, so I can basically run this machine unlimited time. So this is gonna be really awesome, and I'm gonna also bring you some content from the academy as well. So as you can see, I am going with the bug bounty path here. Almost 55% is completed. So once I'm done with this path, I'm gonna bring you the review of this path as well. So stay tuned. This year gonna be really awesome, and we'll be learning a lot together. So let's get into it. So I have cleaned up a lot of tabs here. So today's video, we're gonna go with the OWASP 10 Top 10 2021. There are a lot of tasks here, close to 23. So I'm gonna create 2-3 videos out of it. So it will take like 3 hours to complete everything. Okay, so maybe 3 to 4 videos I will create. Okay, so let's start it. OWASP Top 10 2021. Learn about and exploit each of the OWASP Top 10 vulnerabilities, the top most critical web security risks. So it was created in 2021. Let's see if they have revamped it or not. So let's search it online and let's see. They still have top 10, but what about, yeah, it still have the 2021 version of top 10, as you can see. Yeah, they have 2024 as well, which was their 4th months ago. Data presentation. Okay, this is something else. I mean, data analytics plan or something like that. I think we are still on the latest one here. Let me know, guys, if just a moment, if we are exploring the right content here or not. OWASP Top 10. Let's go to it. Okay, so OWASP Top 10 2025 is there. So we're gonna still go with the 2021 because this is what is available right now. Let's see if we have anything available here. So let me search and see, do we have 2025 here? So there was OWASP Top 10, which I already completed. It was a walkthrough as well. I'm not sure which version of that I had done. Just a moment. They haven't told us which version we were doing, but I think this is the latest version maybe I have done with. So since the other room is part of the path, so we're gonna complete this anyway. So our attack box is available now. We are 4 minutes into the video. I'm gonna mark this video so that all of you guys who just want to start learning the room directly, so you can just click on the link and land here. Okay, so introduction, task 1. This room breaks each OWASP topic down and include details on the vulnerabilities, how they occur, and how you can exploit them. You will put the theory into practice by completing sporting challenges. So we have from 1 to 10. We have broken access control, cryptographic failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failure. Software and data integrity failures, security logging and monitoring failures, and server-side request forgery, SSRF. So, do we still have the same here? Yeah, they are still depicting 2021 here. So all of them are latest. Okay, awesome. This room has designed for beginners and assume no previous security knowledge. Awesome. Let's go and start our machine. Accessing machine. Some tasks will have you learning by doing, often through hacking a virtual machine. First, let's start the virtual machine by pressing the green start button. We already done so. Just a moment. Yeah, it is off, so we are good to go. To access this machine, we can either connect to the OpenVPN. I'm gonna go with the attack box. If you don't have attack box, so you're going with the free subscription, I think you can just go through the OpenVPN. One of my video will explain you how to connect with the OpenVPN. Just search on my channel, you will find it. Okay, I'm gonna complete these 2 tasks out of the way. Let's go with the first, broken access control. So websites have pages that are protected from regular visitors. For example, only the site's admin user should be able to access a page to manage other users. Of course, if a website visitor can access protected pages they are not meant to see, then the access controls are broken. Okay, so there are multiple things here. Okay, so in the monolithic application, if you know about the monolithic architecture of the application, so the protected and public website was part of just one binary and you could just publish it. Okay, so for example, if you need to access the admin page of TryHackMe, you can just go with like tryhackme.com and then the admin, and that means the admin page is also available openly on the internet. This is a bad way to protect your protected pages. The protected pages which is internal to your organization should not be published to the internet, and if it is published, then block it. Nobody outside of the network should be able to access the admin URL. Okay, so this is how you protect it. So now if you're moving towards the microservices, or you are already using the microservices, you know about these concepts already. If you don't know about this, if you don't have any programming or the software engineering background, it's okay, or the web background, it's okay. We're gonna learn a lot this year. I'm gonna bring a lot more content on this channel. A regular visitor being able to access the protected pages can lead to the following: being able to view sensitive information from other users, accessing unauthorized functionality. Simply put, broken access control allows attackers to bypass authorization, allowing them to view sensitive data or perform tasks that are not supposed to. Okay, for example, a vulnerability was found in 2019. What is that? So it is stealing your private YouTube videos 1 frame at a time. Wow, man. Okay, using the post and the cookie and whatnot. So this was a vulnerability in YouTube itself in 2019. Okay, just check it out. I'm gonna just close it. Where an attacker could get any single frame from a YouTube video marked as private. The researchers who found the vulnerability showed that he could ask for several frames and somewhat reconstruct the video, since the expectations from a user when marking a video as private would be that nobody had access to it. This was indeed accepted as a broken access control vulnerability. Awesome, man, awesome. So since we are doing the bug bounty hunter part, so I think once we are done with it, we'll be doing a lot of these kind of vulnerabilities. Okay, Awesome. Task 4, broken access control. It is IDOR challenges. Okay, so IDOR challenge, I can see a lot of things on Axe. The people who are doing the bug bounty programs, they find a lot of IDORs, and they are earning a lot of good money on getting the IDOR vulnerability in some websites. So it is a very good way to earn bounties as well. Insecure direct object reference, IDOR, or insecure direct object reference refer to an access control vulnerability where you can access resources you would not ordinarily be able to see. This occurs when the programmer exposes a direct object reference, which is just an identifier that refers to specific objects within the server. By object, we could mean a file, a user, a bank account in a banking application, or anything really. For example, let's say we are logging into our bank account, and after correctly authenticating ourselves, we get taken to a URL like this, which is bank.thm, then the account number. This is a bad practice to put the account number in the the URL itself. It should be a post request or something like that. On that page, you can see all our imported bank details, and the user would do whatever they need to and move along their way, thinking nothing is wrong. Do we have this particular URL available or whatnot? Just a moment. Let me open up in web browser here. Okay. So we need to put some username and password here. Why we need to put username and password, man? Okay, let's continue. On that page, we can see all our important bank details is listed here. There is, however, a potential huge problem here. Anyone may be able to change the ID parameter to something like this one, 222 and 222, and if the site is incorrectly configured, then he would have access to something else, someone else's bank information. Yeah. So if you don't have, the authorization is not implemented, that means the J clerk can access anybody else's account as well. The application exposes a direct object reference through the ID parameter in the URL, which points to a specific account. Since the application is not checking if the logged in user owns the reference account, an attacker can get sensitive information from other users because of the IDOR vulnerability. Notice that the direct object reference are not the problem, but rather that the application does not validate if the logged in user should have access to the requested account. This is very true. So IDOR, so this kind of vulnerability not just could be used for IDOR, it could be for SQL injection and many other vulnerabilities. For example, if there is a command injection could be done by doing something with the parameters, and you can also read the files on the server using the parameter in the URL. Read and understand how IDOR works. We've done so. Deploy the machine. We already done so. Log in with the username. Root and password is this one. Okay. Root and password is test 11234. Okay, we logged in. THM note server. Things to buy from store: 2 cats, 1 potato, 1 cheese, lots of chocolate. Okay, we've done so. Look at other users' note. What is the flag? Sure, so let's go with the 2. And we don't see any flag here. Let's go with 3 maybe. which means you are on the right track. You are not supposed to see this node. So they simulated everything, right? So it's a good way to do that. Mark's New Year resolution, write actual resolution, go to the gym for real. Hint: do note ID start from 1 and maybe go lower. Really? So let's go with 0 then. Yay! Here we go. The flag 5, 4, 3. So here is our first flag. We did it, guys. So let's move on to the second, cryptographic, since we have time. Okay, task 5, cryptographic failures. Cryptographic failures, a cryptographic failure, if I pronounce it right, refers to any vulnerability arising from the misuse or lack of use of cryptographic algorithms for protecting sensitive information. Web applications require cryptographic to produce confidentiality for their users at many levels. Take, for example, a secure email application. When you are accessing your email account using your browser, you want to be sure that the communication between you and a server are encrypted. That way, any eavesdropper trying to capture your network packets won't be able to recover the content of your email addresses. Yeah, this is true. If he is using forward secrecy or forward secure algorithm. So if he captured your traffic and decrypted somehow, so he can see all the traffic that you have sent or received on your network. If it is not using the forward secure algorithm. If you are using forward secure algorithm, then the part of the encrypted traffic that attacker have decrypted, he will be able to see, but the moving forward, he will not be able to see the he will need to do another round of decryption in order to see the traffic. Okay, so forward, always use forward secure or forward secrecy algorithms in the cryptographic as well. When we encrypt the network traffic between the client and server, we usually refer to this as encrypting data in transit. That is very true. So for example, we are using if a website, for example, this one is using if the connection is stored, that means it is using HTTPS, and if it is using HTTPS, that means there is an SSL certificate, and if there is an SSL certificate, that means once we establish the connection, we basically use Diffie-Hellman algorithm to basically come up with some parameters that we gonna use in the communication between my browser here and the TryHackMe server. So all of this, I think I have explained in great detail in one of my videos. Just check it out on my channel. You will get to know all of this. Check the DevSecOps path. I think I have explained all of this in a great detail there. Moving on, encrypting data in transit. Since your emails are stored in some server managed by your provider, it is also desirable that the email provider can't read their client's email. To this end, your email might also be encrypted when stored on the servers. This is referred to as encrypting data at rest. So there are two ways to encrypt, right? So one is, okay, so I received an email. It will be, for example, if you are using Gmail, so this email will be stored on the Gmail server, right? So once it is stored, I want it to be encrypted once it is stored as well. So for example, if somebody is trying to, if the storage of the Google is compromised and somebody trying to read my email, he will not be able to do that unless he have the public key or the private key from where or by using which I encrypted the data. So if he don't have the private key, he will not be able to see or read my data because it is encrypted. If he tries to read it, it is encrypted. He will not be able to make any sense out of it. Okay, so this is data at rest encryption, encryption at rest, and then we have encryption at transit as well. So encrypting data in transit and encrypting data at rest. So both of the concepts are there. We need to familiarize ourselves with both of them. Okay, so both of them are used in web application development, especially. Okay, cryptographic failures often end up in web apps accidentally divulging sensitive data. This is often data directly linked to customers, name, date of birth, financial information, but it could also be more technical information such as username and password. So you never store password as a clear text. You always go with hash, and even hashes are not used directly. You use some kind of salt with hash to make up a user password hash. Okay. At more complex levels, taking advantage of some cryptographic failures often involves techniques such as man-in-the-middle attacks, whereby the attacker would force user connection through a device they control. Then they would take advantage of weak encryption on any transmitted data to access the intercepted information, if the data is even encrypted in the first place. Of course, many examples are much simpler, and vulnerabilities can be found in web apps that can be exploited without advanced networking knowledge. So this is basically man in the middle. Usually, it is rare in the sense that most of the communication are secure nowadays. And if somebody needs to go with the man in the middle attack, that means he needs to compromise your network physically or maybe virtually. Okay, if he can. This is a very advanced concept, and most of the people will not be able to do that. So what happens is we are trying to find some vulnerabilities which can give us the direct access to the web application server, the backend server itself, and then from there we can pivot around to other servers and trying to enumerate the network itself and trying to find what is available within the network. And then a few steps along, we exfiltrate data, and then we just close the connection or basically clear up the logs. Okay, so all of these I have explained in the SOC 1 playlist. Just check it out. We have explained how the method, how the attacker will go around enumerating and basically the kill chain of the attack, how the attacker will do it. Of course, many examples are much simpler, and vulnerabilities can be found in the web apps that can be exploited without advanced networking knowledge. That is true. Indeed, in some cases, the sensitive data can be found directly on the web server itself. The web application in this box contains one such vulnerability. To continue, read through the supported material in the following task. Sure. So we have completed this. Let's go with the supporting material 1 with task 6. So cryptographic failures, supporting material 1. The most common way to store a large amount of data in a format easily accessible from many locations is a database. That is very true. This is perfect for something like a web application, as many users may interact with the website at any time. Database engines usually follows the structured query language. So this is one way of storing the information. There are no SQL databases as well. And now in the on the cloud side, we have blob storage as well, where you can just store object into the storage as well. So there are a lot of databases available in this context. Okay, so one of them is SQL, structured query language. We call it RDBMS, relational databases. In a production environment, it is common to see databases set up on the dedicated servers running a database service such as MySQL or MariaDB. However, databases can also be stored as files. These are referred to as flat file databases, as they are stored as a single file on the computer. This is much easier than setting up an entire database server and could potentially be seen in small web applications. That is very true. Accessing a database server is out with the scope of today's task. Okay, so let's focus instead on flat file databases. All right. As mentioned previously, flat file databases are stored as a file on the disk of a computer. Usually this would not be a problem for a web application, but what happens if the database is stored underneath the root directory of the web application website? For example, one of the files accessible to users connecting to the website. Well, we can download and query it on our own machine with full access to everything in the database. Sensitive data exposure indeed. This is a big hint for the challenge. So let's briefly cover some of the syntax we would use to query a flat file database. The most common and simplest form of a flat file database is a SQLite. An SQLite database. These can be interacted with in most programming language and have a dedicated client for querying them on the command line. This client is called SQLite 3 and is installed on many Linux distributions. So we already have a SQLite here. So let's see SQLite 3. Okay, so we can mention the file we need to open. So we don't have any file, so let's exit it. Quit. Control C. Yeah, so if you do the Control Z, it will put the process in the background, and once we run it again, it will come back again. All right, let's suppose we have successfully managed to download a database. Okay, let's see, do we have a database here? We don't have any database here. So example.db is here. Okay, file example.db. So it will say that, okay, this is SQLite database with some version and whatnot. We can see that there is an SQLite database in the current folder. I can't see any SQLite database here. All right. So what we do is SQLite and then the name of the database. So once we do that, we have all the information here. Dot tables will give you the table names of the database itself. At this point, we can dump all the data from the table, but we won't necessarily know what each column means unless we look at the table information. First, let's use Pragma table info customers to see the table information. Okay, we don't have any database here, right? So how are we gonna go all? Okay, let's see what we have here. So Pragma space table info, and then we pass the customer. So we have CRUD ID, which is integer. We have customer name, cost name, it is text, and then we have credit card information, which is text, and then we have password, which is also text. So if we go with the select static from customers and then semicolon, then all the information will be displayed in this format. Okay, we can see from the table information that there are 4 columns: cust ID, cust name, and credit card and password. You may notice that this match up with the result. Take the first row. Here we go. So this is credit card information. They store directly here. Wow. We have the cust ID 0, cust name, customer name Joy Paulson, and the credit card information is this one, and the password hash is this one without salt. In next task, you will look at cracking this hash. Okay, so cracking hashes can be done at scale with minimum hardware requirement. Okay, and there are some websites as well which will help you do that. Cryptographic failures, supporting material 2. So we're gonna close our today's video on this task. So once we come back, we're gonna go with the cryptographic failure challenge. We saw how to query an SQLite database for sensitive data in the previous task. We found a collection of password hashes, one for each user. In this task, we will briefly cover how to crack these. When it comes to hash cracking, Kali comes pre-installed with various tools. If you know how to use these, then feel free to do so. However, we are out with the scope of this material. Instead, we're gonna use the online Crack Station. Crack Station is a really good database, and they have basically database on their side. We just need to paste the hashes here. They support, as you can see, a lot of hashes format, and if they have any kind of hash in their database, they will display you the actual string, okay, against that hash. This website is extremely good at cracking weak password hashes. For more complicated hashes, we would need more sophisticated tools. However, all of the crackable password hashes used in today's challenge or weak MD5 hashes, which CrackStation should handle very nicely. When we navigate to the website, we are met with the following interface. That is true. Let's try pasting the password hash for the Joy Paulson, which we found in the previous task. Let's do that. Crack hash. So the result is password here, and type is MD5. So we are able to exact match is there, and the password is password string. We solved the CAPTCHA, then click the crack hashes button. We did so already. So we see the hash was successfully broken and the user's password was how secure. It's worth noting that the CrackStation works using a massive word list. If the password is not in the word list, then the CrackStation will not be able to break the hash. The challenge is guided, so if CrackStation fails to break a hash in today's box, you can assume that the hash has been specifically designed not to be crackable. Okay, so thank you guys for joining me on this journey. So once we come back, we're gonna go with the task 8, and we're gonna go with the cryptographic failure challenge itself. So I'm gonna close the video, and once we come back, we're gonna resume the video from task 8.